What I'm showing you today is how I constructed a vibrating screen and glaze mixing setup. And first we're going to look at the glaze mixer itself, so you'll see it from top to bottom. This is the 1-horse motor. It's a 120 volt. There's the bearing assembly. There's the end shaft, and of course this is the stand. And if you look where that L-shaped angle is right there, I'll show it to you first. What you're going to see is it's nothing more than a bolt welded in there. Come on. Doesn't even want to focus very well. But it's just an L-shaped bolt welded to a nut on a pipe. There, that's much better. You can see it. And that's a stop bolt, so it won't drop all the way in. We'll pull back. Now we're going to look at the bearing assembly. You'll notice that there's a jaw coupling that fits the motor, because the motor has one size shaft, and then the drive shaft for the propeller has to have two bearings so it won't whip around. So everything was aligned very accurately with a metal drilled bushing first, and then the actual bushings were put in afterward, the couplings I should say. And if you look down the shaft now, watch this. At the end there's a welded prop, and I made a template and drew it up on masonite, taped it down, and then cut it out using a scroll saw so that we get a perfectly symmetric prop that runs really smoothly. And that's a 1/2-inch stainless steel shaft and 2 1/2-inch high-speed bearings. So now what I'm going to show you is how we zoom out. We'll go out and we're going to look at it. I'm going to put a bucket of glaze in there, and I have a bucket that I prepared yesterday, so this simply swings out of the way. This is settled from yesterday. It hasn't been screened yet because we're going to move to the screen right after I set this up and get it running. So this idea here is that you can lift this straight up, set it right in the bucket, then you drop it down to the correct position, and this handle simply holds that up into position. Then I'm going to carefully position the bucket just that way, and I can switch it on. Now, while that's running, we're going to back up, and we're going to look over here, and you can see there's a router speed control right there. So I can change the speed of mixing to anything I want. So that's certainly sufficient right there to mix that, and you can see it's quite thick. So while that's mixing, I'm going to swing over here, and we're going to look at the screen next. So I'll move over to the screen. We'll look at it. Here's the actual screen that we're going to be dealing with right here. I may have to elevate this a little bit so we can see it better. So down at the bottom there is a frame. The frame has a reflector, and I'll take that out and show it to you. This is a reflector right off a portable lamp, and I found ones that were this size, so I built all the machinery to fit that. Next thing we're going to look at is the frame, and you can see that it's just a simple angle iron frame, but look right there. Here we're going to zoom in a little bit, and you'll see the bearings. And I'll turn this 180 degrees so you can actually see it. This is a pillow block, and that's a pillow block, and this is a 1/2-inch shaft. Between them are pieces of shafting, about 2-inch shafting, and you'll notice that the hole is drilled most of the way toward one edge, and there's a set screw hole put here and one put here. And what this allows you to do is, if these were exactly opposite each other, they would not vibrate at all. But when they're partially both on the same side, they create a lot of vibration. And so, the next thing I'm going to show you is, I'll back away a little bit. I'm going to show you how easy it is to install a screen in here. The particular screen I'm using, right here, this is 100 mesh. And so all that's happened is this is a stainless steel flange I constructed, which is simply cut out as a ring. And this is a rolled flat ring that'll fit inside of a 4-gallon bucket. then it's the screen material is stretched tightly over with help, and then these large radiator hose clamps, it takes more than one to clamp that tightly, and you can see then it can be fastened, and then it's caulked inside with silicone rubber so it won't skid or leak. So now, the next thing I'm going to do is put this down over top, and I use what are called flange nuts. That's a thing that looks like this, and I'll put one right here. And I'll put one right here. On the opposite side, you don't have to have four. Just like you're going to shut it down. And for good results, I use this special magic material called WD-40, and I'll put a drop of oil on here so that it doesn't fall. And then I'll put a drop of oil on here so it doesn't fall, because if this is exposed to water regularly, the problem you'll run into is it will sometimes get a little goofed up and then it won't go. I'm using a Ryobi impact driver because this is how fast it is to put it together. Yeah, it's ready to run, and just coincidentally, it's already mixed up. So here's the surprise. I'll shut that off, lift it out, set it over here, and now I'm going to turn it on. There's just an on switch. Just going to have to plug it in first. Where did I put the cord? It came through here. Okay, forgot to plug it in. Here it is, with it plugged in. And if it spills like that, it's mostly because I poured a little quicker than I should have. But you can see that since it's a glaze, virtually all of it went through because it's all 200 mesh or finer, and this is a 100 mesh screen. And the main purpose of screening it to 100 mesh is to get any irregular material that might not belong. Okay, so now we're going to look at this all the way from the top down. If you look right at the very top, you can see right away that this is a washing machine, a really old washing machine motor. I got that at a yard sale for $1, and that's not a joke. So there it is. And since it didn't have any mountings, what I did was I constructed a mounting that looked like that. And it's got a U-shaped piece of material welded, and then that's a piece of pipe that holds the rubber bushing that came with the motor, which sat in a cradle. This is an open frame motor because it doesn't need to be dust tight. We're not really working with dusty materials. Since that's a 1/2 inch shaft on this motor, and this is a 1/2 inch shaft here, what I have is just a simple flex coupling there. And then look down here. This is the top of that shaft. It has a small bearing mounted in there that keeps this lined up with the motor. The reason you have to have that is look how long this shaft is. The shaft is almost 20 inches long, and when we get down to the place where it shakes it, you can see that's too long a shaft length for you to not have it supported at the top. The old conduit you see here is simply the first frame I tried, and it broke too easily, so I replaced it with a simple 1-inch angle iron frame, and the 1-inch angle iron frame then goes down to where you have the two bearing mounts. And this is the way the bearing mounts are set up. They're welded across like this, and then they have vertical webs that help stabilize them and keep them parallel, and then they're welded very sturdily to this bigger angle iron, because remember, the motor is acting like an anchor. It doesn't even vibrate. This vibrates the thing in an oscillating direction, not up and down. So it quickly shakes the material, and then when it gets down to here, this thing right here is actually oscillating violently. And once you have the material all out, then it's a simple matter to take the thing back off and wash it.